Hey, Eris.
Hey, Astra. Are you here to give the tour?
I thought you were going to take a personal day.
Yeah, I'm covering for Jackie. Apparently the police are here questioning her about that scientist that never texted her back.
Are you serious? What happened?
She's missing. Jackie came out of the bathroom at that bar, ready to go to the research lab with her, and poof, no sign of her since.
Well, hopefully that makes her feel a little bit better about being ghosted.
I don't know. I just hope everything turns out okay.
Surprise! Bet you didn't expect to see me, Nobel Prize winning scientist, Science Tomathan Partridge. I have the crown to prove it, as all Nobel Prize winners receive.
Of course the tour I just covered has this kid again.
Have fun with that.
Look at you, Mr. Nobel Prize winner! Such a handsome young man. Now, why don't you go ahead and take your seat? The tour is about to begin.
I resent your condescending tone, as I assure you, I am a grown adult.
Sure you are. Welcome, friends, to the final black hole tour. I'm your space tour guide of space, Astra. We have a beautiful day here on TRAPPIST-1E, so thank you for spending it with us and choosing Space Expedition. We know you have a ton of choices of tour guide companies, so thank you for choosing us. In the previous two tours, we covered black hole theory and observations. Click the link to check those out if you want to know more. Today, we're going to be talking about Nobel Prize winning research on black holes, the dramatic rivalry between scientists, and how the field of astronomy is a little different than other scientific fields. Welcome to... I almost got through my intro uninterrupted this time. Hold on a moment. Give the child a distraction, its toy. I keep the stone because you can never tell where the crying is coming from. And they left. Excellent, okay. Welcome to Bad Astra.
Fine, let's get to the science content.
Why?
We need to talk about polyamory.
Remember when Pluto was demoted to dwarf planet?
It's okay, man. We all make mistakes.
Isn't physics fun?
Is this being recorded? In 2020, 3 scientists received the Nobel Prize for their research regarding black holes. Roger Penrose set the stage back in the 1960s by looking at Einstein's theory of relativity, specifically the parts talking about gravity and warping space-time, and going, so what if we take this math, and stay with me here, turn it up to infinity because we can. It turns out that when you go all the way with math, it turns into a black hole. The formation of black holes was, in fact, predicted by general relativity.
As a fellow Nobel Prize winner, I too often take things and turn them up to infinity to see what happens. The technical term in the field, dear Astra, is walk around and find out.
I find that very suspicious, but the energy of that statement is true. That's a lot of what science is. Anyway, the other half of the prize was split between 2 rival scientists, Andrea Ghez and Reinhard Genzel.
Rockhard and I are good friends. We go way back.
I highly doubt that, seeing as you're an undisclosed age between 11 and 13. Also, can we please show a little respect for the Nobel Prize winners?
Why don't you show more respect for the Nobel Prize winner sitting in front of you?
I will not indulge in your fantasies of grandeur.
And I will not indulge in your grief-fueled fantasies of being a space tour guide in $23.95.
They're not, I get paid to, whatever. So Ghez and Genzel were both awarded the other half of the Nobel Prize for the discovery of a supermassive compact object at the center of our galaxy. They started in the 1990s, Genzel heading to Chile and Ghez heading to Hawaii 3 years later. 2 rival teams racing to find evidence of a supermassive black hole at the center of our galaxy by tracking the stars orbiting Sagittarius A star. For more details on that, please check out last week's tour about black hole observations.
I did not pay for this tour to get unskippable ads.
You didn't pay to get into this tour at all.
Is my suffering worth nothing to you?
It's worth more than you know, but I'm just trying to get through the workday, okay? How did they actually measure the motions of these very far away stars? Well, Both teams had to develop improved techniques of speckle imaging, correcting for distortions from the Earth's atmosphere through stacked, rapid exposure images. Generally, a lot of exposure time is needed to gather enough light to see a faraway object, since they are, less bright. The easiest way to do this is through long exposures. Leave the camera's shutter open a while so enough photons are detected. The Hubble Ultra Deep Field consisted of multiple observations of the same patch of sky combined for an equivalent exposure time of 11 days. However, long exposures make it difficult for observers to account for and remove atmospheric interference, since the atmosphere changes over time. Speckle imaging overcomes this issue by using tons of rapid exposures 1/100th of a second long, rather than one long exposure. These snapshots allow astronomers to see the instantaneous speckles in the atmosphere, rather than having the atmospheric changes blur over time. These snapshots can be individually cleaned, removing the atmospheric speckles before being stacked together for a final image.
Alright, most of that I didn't get, and the parts I did sound fake.
These improved speckle imaging techniques, developed by Gez and Genzel's teams, dramatically improved other astronomers' ability to take accurate measurements, in addition to tracking the orbits of stars at the center of the Milky Way. In 1997, both groups released their measurements pointing to a black hole at the center of the galaxy due to the surrounding star's motions. Then they went back to their telescopes and took advantage of adaptive optics, a new technology at the time. Adaptive optics is where you shoot a laser into the sky, exciting atoms in the atmosphere and creating an artificial star for your telescope. Since you know what the star should look like, assuming you read the laser's user manual, you can reverse engineer the atmosphere's effect on your fake star. And rather than correcting during post, you can adjust one of your laser's mirrors in real time to account for the atmospheric distortion. You have a computer constantly calculating atmospheric distortion in real time and adjusting one of the telescope's mirrors accordingly. Adaptive optics allowed Genzel and Gez to capture even more complete stellar orbits, presenting bulletproof evidence that there was a supercompact object, a black hole, at the center of the Milky Way, around the same time. Again. So they both get to share 1/2 of the Nobel Prize, which is great. Super awesome. They both get to share the glory of victory after decades of competition. It's like if Midoriya and Bakugo's teams in the battle trial tied and they had to share the victory. The story of two rivals pushing each other to the top through pure competitive spirit and mild hatred is a tale as old as time. Huh. I didn't realize Eris was a weeb. Don't look at me, I only know as much as you do. Anyway, the 2020 Nobel Prize distribution shows how astronomy works a bit differently than other scientific fields. Theory leads to observation because of how big space is. In other fields, theory leads to experimentation. This is more reminiscent of the scientific method you learned in school. However, if you want to figure out what the sun is made of, going there, grabbing a sample to test on, and then returning to Earth is impossible, a lengthy ordeal if you could, and would cook you alive. Don't you dare move from your seat, Science Tommy, or I will turn this spaceship around. I was not going to do anything like that. Flying too close to the sun without solar filters would be an insane death wish of an overconfident AI with a malfunctioning GPP program. I was just going to embrace the scientific method of walking around and finding out. Good news is that space is so big that even though you can't create specific scenarios, you can probably find examples of them by looking at the sky. In astronomy, you just have to see the thing and take a pic to prove it exists. It's basically a game of I Spy in a dark void using very expensive telescopes and hoping you carried the right number over in your big fancy equations. Or not seeing something and winning a Nobel Prize for it. Again, they took a pic of all the evidence, so it still counts. I'm not going through this again. The point is, you do the math, then play I Spy, then do a bit more math. Sometimes you find what you're looking for. Sometimes you find something you weren't expecting. It's kind of like true love, both in the romantic and the platonic sense.
Or like when you find a place that will give you guac at no extra charge.
Truly the dream right there. Or like when you're Jocelyn Bell and discover a pulsar. Or when you're Cecilia Payne and discovered that stars are mostly hydrogen and helium by using Annie Jump Cannon's spectroscopy catalog, thus completely shattering pre-existing consensus and paving the way for our modern understanding of the nuclear fusion powering stars.
That is not at all like guac.
For more info on nuclear fusion, both in stars and out,
Can we please skip this ad?
not until we're monetized. Check out our long-form essays, Even Stars Must Die, and What Can We Learn from Sharon Noble?
I was in both and refused to watch either.
Astra, this is starting to scare me.
Well, that concludes our 3-part black hole tour. We've gone through the theory behind black holes, our observations, and the 2020 Nobel Prize winning discoveries. Please check to make sure you have all your belongings before exiting the spacecraft. And feel free to explore other black hole related content, including a short science fiction story about entangled black holes, a space shanty, an essay on metaphysics and how black holes help Plato, and an interview with a real LIGO postdoctoral researcher.
Astra, are you okay?
What do you mean?
Science Tommy died in that black hole a few videos ago. And I understand that everyone grieves differently, but this is starting to scare me. I think you should take some time off.
But you're right here. You've been on all the tours.
Astra, take off the costume. Let's get you back to your wife and puppy, and I'll cancel the next show.
I'm fine. See? We hope you enjoyed your tour with Space Expeditions, where you'll go a reasonable distance. Thank you from all of us at Tourist Trappist Corps. Astra out.
Listen, I may or may not have a lot to live for. I don't know. I'm only 8.
Don't look directly into even the weakest of UV lights.
Oh, the space banana. Whoa! Oh, no! This is how it ends.
I very genuinely love learning and doing new things and being very hands-on in the process. So join me as we walk around and find out.
Thank you so much for joining us here on Bad Astra. If you enjoyed watching, please like this video, leave a comment telling us what topic you'd like to see next month, and share it with everyone you know. Be sure to also subscribe and ring the notification bell so you never miss a new episode. And if you can't get enough of me, Eris, and Science Tommy, join our Patreon, where we post behind the scenes, deep dives, and other fun content. A special thank you to all of our Patreon supporters who make these videos possible. Astra out.